Hello, and welcome to some Sudoku. Today I'm going to be doing Hidden Setup by Raumplaner. This is a puzzle TV uh, game, so this is a puzzle that I've seen a bit of before, so I know how to start it, but I don't quite know exactly how it'll continue, so I'd like to be able to do the whole thing here. First of all, uh, these are even digits. Whoops. Those are even digits. These are run-band lands. They must form a consecutive set of digits in any order. Killer cages must sum to the total given in the top left corner and must not repeat. In this case, it doesn't really matter because they're all in a line anyways. Between lines, these values must be between those two cells. Strictly in between those two. And let's go. First of all, the first obvious thing that I see is doing a little bit of fancy Sudoku trickery. Set theory. This is 4 sets of the digits 1 through 9. This is 5 sets of the digits 1 through 9. So yellow and red together the yellow contains one more set of the digits 1 through 9 than red. And even if we remove all of these, that still remains true. It is red, but with an extra set of digits 1 through 9. And here, 1, 2, 3, 4, 5, 6, 7, 8, 9, we can remove that, and that still remains true. Notably, you'll also see here, this is a set of digits 1 through 9, and this is a set of digits 1 through 9. So now we still have yellow is equal to red. That's interesting, because these say that they're all consecutive, but this implies that the most extreme numbers end up on these little bids here. So how can we reconcile that? First of all, we'll remember this and say yellow equals red. We can deal with that afterwards. We'll tackle that in just a second. But first, I want to come here and say the lowest possible way that we can do 12 in 4 digits would be 1, 2, 3, 4. So we have 10. So we only have 2 degrees of freedom. So we could do 1, 2, 3, 6, or 1, 2, 4, 5. No matter what, there's a 1, 2 in it. Here, 28, the highest number we could do would be 9, 8, 7, 6, which is 30. So again, 2 degrees of separation, which means there isn't a 9 or 8 here. Here, these are all different digits, but they're all even, so you must have 2, 4, 6, 8, and they're all different. Notably, 2 away from 8, 2, 3, 4, 5, 6, 7, 8 is the full host of everything here. 3, 5, 7, which means the most extreme digits we work with are 2 and 8, which means these must be 2, 8, and these are all the other digits. 3, 4, 5, 6, 7. Notably, 1, 2 is there, so this has to be an 8. That has to be a 2, which means that can't be an 8, which means that's an 8. Excellent start here. Notably, also, this also means that these can't be 8. They also can't, they could be 2 in theory, because this could be a 2, and then one of those could be. But yeah, so that's basically where the whole puzzle starts. I don't know what the yellow things are here. Oh, in later stages, there will be additional clues. So I've got to reach a certain point before more clues will be given to me. Okay, so we have to have a 9 here. Now, I don't know what to do preceding this. This has one set of digits 1 through 9, so 8 has to be somewhere here. 2 can't be there or there, so 2 has to be here. And then, so now that means that we can't have a 2 here. We can't have a 2 here, which means that must be 2, which means this can't be a 2. Which means either this is a 2 or that's a 2. There is no in between. Yeah, that's cool. Okay, well, we've got the 2s here. 3, 4, 5, 6, 7s. What else do we have? Well, as I said, we have a full set of digits 1 through 9 here. I don't see anything else immediately apparent. So this is 1, 2, 5, 6 potentially, and that would be 3, 4, 7. This can't be a 9. There has to be a 9 right here then. Because no other, so you can't put a 9 there. This could be what? 1, 2, 5, 6, which means this has to have a 7 in it. Which means that cannot have a 7 in it. but it could be 1, 2, 5, 6, which case this is 3, 4. Or it could be, sorry, yeah, 1, 2, 5, 6. Or 1, 2, 3, 6. Sorry, in which case this is 4, 5. Or 1, 2, 4, 5, which case this is 3, 6. So I'm going to get 3, 6, or 4, 5 with a 7. 3, 6, 4, 5, and 7. Yep, makes sense. Makes perfect total sense. Likewise here, what digit can we not have here? Well, 9, 8. We 9, 8, 4, 5 is the lowest we could go, I think. 17 plus 28, yeah. So we can't have 1, 2, or 3, which means 1, 2, and 3 need to be here. Interesting. So 1, 2, 3 need to be here. Oh, well, this has to be a 1. Which means that can't be a 1. Whoops. Which means that can't be a 1. Okay, that makes things a little bit easier, I guess. Now since we don't have 2 anywhere else, this has to be a 2. Go to the next stage. Shit, okay. Oh, so I've got to get what these yellow cells are in order to get to the next stage. Okay, so this is equal to that. That is equal to this. Arrows. Digital long arrows sum to the numbers in the circles. So these can't be 2. This is 15. So this has to be either 7, 8, or 6, 9. This has to be, well, it can't be 1, 4, so it has to be 2, 3. Which means that can't be a 3 because that's the same digit here. This is 14, and so it's either 8, 6 or 9, 5, but it can't be 9, 5, so it has to be an 8. I mean, we could also know that that can't be an 8 because of this. But yeah, 6, 8, which means we've got 1, 2, 3, 4, 5, 6, 7. So 4, 5, 7 to work with. So that can't be a 3 or a 6. That can't be a 4. Cool, okay. So now what do we have with this? This could either be a 1, 6, which it could still be, or a 2, 5, which it could be, or a 3, 4, which it could be. Actually, could it be? Yeah, it could be, because that could be for 3. That could, or wait, 3, 4. Yeah, okay, it could be any of the above. Yeah, that's fine. So we have here. So whatever's missing from here could go here or there. So that 5. Well, 6, 8 can't go here. Actually, 6 can't go there. At all. So yeah, 6 is blocked out of this. Because of that. Because of the existence of this. Which means 6 must go here. Which means 6 doesn't go there or there, so there must be a 6 here. So if we have 9, 8, 6, that adds to what? 15, 23, 5. So it's 5, 6, 9. Which means this can't have a 2 in it. Which means that must be the 2. That must mean that this is, what, 1, 6? Well, no, 6 has to be here. It has to be 3, 4. Which means this can't be 3, 4. Which means, since this can't have 1, 2, 3, 4 in it, and it has to have a 3, this has to be the 4. Which means that has to be the 4. Which means that can't be a 4. This has to be 1, 2, 3, 6. No, that doesn't add up, does it? Okay. So does that up? 15, 20, 28. Yeah. So this can't be an 8. So this still has to have 6 in it. Period. We just know it has to have 6, which means this doesn't have a 6, so that's still correct. This can't be 2, 5, so this must be the 2. I'm still correct about this. That can't be 1, 6. That can't be 2, 5. It has to be 3, 4. But there's also, okay, so this has to have 1, 2, 3. So let's just eliminate all that. So it has to be 1, 2, 3. That makes, yes, it has to be 1, 2, 3, 6. But then you can't put 6 here and it breaks. You have a 6 on there. Okay, let's go right back to... Oh, wait. Okay, so, notably, 14 is either 8, 6 or 9, 5. Can't be 9, 5, has to be 8, 6, 8. This can't be a 6. 6 could still go there. That's what I did wrong. Oh, no, it can't. Because if this is a 6, then that's a 6. That has to be 2, 3. Which means this is 4, 5, 7. That can't be a 4. That can't be a 3. One of those then has to be a 4. Don't know which one. But yeah, then 6 has to go here. Which means 9, 8, 7, 4? Is that what it is? Yeah, that's 9, 8, 7, 4 is what it should be. I think that's where what I dicked up. That should add up correctly, not 5. Because 7 plus 4 is 11. 11 plus 9 is 20, 28. Okay, there we go. Fixed. Repaired successfully. Then this still can be 2, 5. Can't be 3, 4. Could be 1, 6. But we can't have a 4 here. So, whoops, we can't have a 4 here. Six has to be here, so 1 can't be there, so this has to be a 1. Okay, there we go. Things are now adding up better. Means 2 has to be here, which means that's a 2, 5. This can't be 7, which means that's the 7, that's a 7, that's a 5, that's a 5, that's a 4. Okay, we're now getting there. This is 1, 4, 5. Which means this can't be a 4, that can't be a 5, that can't be a 4. Means this is 2, 6, which means this can't be 2, 6, which means that can't be 2, 6. And this also can't be a 5. Also can't be a 3, because there's a 2, 3 right there. So that's a 7, that's a 3. This can't have a 3. It's a 4, 5 pair. Sweet. What can this be? This can't be a 6. Can't be a 9, so it's a 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9. Go to the next stage. So those corners are now even digits as well. Sweet. This is an even digit implicitly. That is an even digit, so that has to be a 2. That's a 3. This isn't implicitly an even digit, even though it is. Doesn't matter. We just, this has to be a 4. This has to be a 1. Whoops. 1, 2, 3, 4, 5, 6, 9. So 1, 6, 9. This is 1, 2, 3, 4, 5, 6, 7, 8, 9. Do we have 3, 6 anywhere guaranteed? 6 has to be there. So that's a 3. That's our 6. Sorry. This can't be 2 or 8, so it must be 4 or 6. This can't be 2 or 4, so it must be 6 or 8. This can't be 4 or 2, so it must be 6 or 8. Ah, these both see 2 and 4, that has to be 6, 8. Which means that must be a 2, that must be a 6. That sees 8 and 2 as well, which makes that a 4, 6. Which means that can't be a 4. It has an 8, 6, 4, 6. We have a Y-wing on 6. Is that what it is? No matter what, there has to be a 6 here. And no matter what, there has to be a 6 here. Which means no matter what, there's going to be a 6 somewhere here. And there's going to be a 6 somewhere here. Which means that's an 8. That's a 7. That's an 8. Haven't actually deciphered that yet. No matter what, there has to be a 6 here, so that can't be a 6. That isn't necessarily an 8. I'm just going to start placing possible digits. Oh my, I wasn't going to have to do that. We have all the even digits here, so we can put odd digits in here. 1, 3, 5, 7, 9. That can't be a 3. That can't be a 9. That can't be a 1. That can be anything. We have 2 odd digits there. We have all the even digits here, so we can put here 1, 3, 5, 7, 9. This can't be a 7 or a 5. This is be 1, 3, 9 as well, doesn't it? Cool. That can't be a 9. That can't be a 3. That can't be a 1. Pretty much anything else is possible. Do I have to color this grid? I really don't want to color the grid. But if that's what it's going to end up making me do. System of Elves bring have something to do with it? I don't see anything here. Oh, there is this, isn't it? Isn't there this formation? Yeah, that formation is going to be nice. Okay, so first of all, let's erase all colors. This is a set formation that I'm familiar with. I'm just going to dye them all yellow just for simplicity because the other ones are already yellow. That yellow equals the purple. So you know that there are 2 2s and 2 8s in the purple. And there are no 6s, which we already knew. How many odd digits do we get? We have 1, 2, 3, 4, 5, 6, 7 even digits. Seven guaranteed even digits. 1, 2, 3, 4, 5, 6, 7. So 7 guaranteed even digits. What do we know? Well, we know that there has to be an 8 here. We know that there has to be a 2 here. Can that be a 2? If that's a 2, then we're forcing 4 2s into these boxes. Well, right now we already have an additional 2 is forced in here. I mean, I don't see any problem with having 4 2s in there. Oh, wait a second. There are going to be how many odd numbers in these two columns? 10. Because it's 1, 3, 5, 7, 9 is 5 times 2. 1, 2, 3, 4, 5, 6, 7, 8. There's only going to be 2 odd numbers in that entire area. If there's 2 odd numbers here... Oh, I didn't even realize. These are all odd as well, because we have 2, 4, 6, 8. So that can't be a 3. That can't be a 5. So there's only 1 odd number here. One, 2, 3, 4. Sorry, 4, 5, 6, 7. Maybe 8. So depending on this, determines if all of these only have 1 in there. What am I missing? How do I fill in those corners? Is it this? Do I have to figure out what that is? So, because whatever this is... that's a triple. Yeah, so that's a... Oh, and there's an 8 here. There. So that makes that a 6, that an 8, that a 4, that a 6, that a 4. Okay, and here we go. And that's what I was mentioning before. So this shows there is exactly 1 odd per, which means that this has to be even. So 9 composed of an odd and 2 evens. Well, you can't have 4. You can have 2 6. Oh, you got, yes, it's 3 evens and an odd. Oh, that's interesting. So it would be 2, 4, 6, 8, but I can't include 4. 2, 6, 8, add up to 16 and a 1. I understand the gimmick with this now. That's cool. Okay. 2, 4, 6. That adds to... This needs a 9 to pair with it. This is 2, 4, 8. Needs a 7 to pair with it. 2, 4, 8. Needs... so that's what? 14 needs a 3 to pair with it. So, none of these can have a 3 in them. None of these can have a 9 in them. None of these can have a 7 in them. None of these can have a 1 in them. or a 2 for that matter. Now, this has to have a 9, which means these can't have a 9. Which means, what else does this mean? This has to have a 3. There we go. That has to have a 3, which makes that a 1. That's a 5. That's a 7. Whoops, sorry. That's a 3. That can't have a 1 or a 5. That can't have a 3. That can't be a 1. That can't have a 5. Could have 3, 7, 9. We can't tell quite yet. So we can't have a 1 here, which means this has to have a 1. Which means that can't have a 1, which means this is the 1. That's 5, 9. This can't have a 5 or 9. These can't have a 7 either then. That's the 9. This can't have a 9. There's no 9 there. This can't have a 3, which means that this has to be a 3 because it's the only digit that's missing. That's an 8, which means 8's forced to be here. There's a 1 over there, so this has to be a 7. That's a 1. Is there a 6 or 9? There isn't. There's a 5, though, so that's a 9. That's a 5. That's a 7. That's a 9. Go to the next stage. Okay, this has to be a sum of this. Which forces that to be a 2 no matter what, right? Because it's 9 for... Okay, 9 for 5. Can't be there, so that has to be a 2. Because either it's 6, 2, 4 or 9, 2, 7. 9, anything 4, there'd be a 5. 6 and 7 doesn't work, and 5 can't be there. Cool. So that can't be a 2. Let me actually just remove those. Doesn't matter. Another one they have here. This obviously can't be a 1, so that's a 9. This could be 5, 4. Oh, this has to just be a 1. Whatever. That's a 3. That's a 9. That's a 5. That's a 3. That's a 4. That's a 5. This can't be a 4, which means that can't be a 5. So it's a 1, 8 pair here. That's a 5. None of these can be an 8 anymore. This can't be an 8. This can't be a 7. 7 has to be down here. This is a 2. So that can't be a 2, which means this can't be a 1, 6. Which means this is an 8. That's a 2. That can't be a 2. We got 4, 7. We got a 7 up there. That's a 4. That's a 7. This can't be an 8, so that's the 8. So don't have 6, 9 quite yet. Oh, yes, we do, because that's a 4. That's a 7. That's a 9. That's a 6. 9 can't go there, which means 4, 6 can't go there. Can't have a 3 there. Can't have an 8, so it's going to be a 4. That's a 3. That's a 6. That's a 3. That's a 1. That's a 6. That's a 5. That's a 1. We're cluing it all up now. 4. That's a 4. That's a 6. That is a 2. That's a 9. And we're done. That is a solid puzzle. Thank you very much for watching. Hope you guys have enjoyed. That was Hidden Setup by Raumplaner. Cute little puzzle. I like how the pieces all kind of like pop together once you got each little individual bit. Really fun. I will see you all next time. Cheers.